Hello everyone, this is going to be a walkthrough of the boot2root machine from our noob2root competition series. I will be going through a little bit of my methodology on how I would have done the box, showing off some extra things that would have helped you on the box and can help you on future boxes, and just trying to talk about some of the problems you might have ran into and why those occurred. I'm on a Mac, so I will be using VMware Fusion. If you're on Windows, you could use Workstation, or if you wanted to use VirtualBox, I know people were doing that at first. I did put out this noob2root T2 OVA, which I'm going to be importing real quick, which solved a little bit. It let you use VMware, so if you were partial to that and had to install VirtualBox, sorry. We have taken that into consideration for if we do this in the future. But also, I tried to fix up some of the problems people might have been having, made it a little easier to see the IP address of the box, which I'll show off in just a second. Before I boot up the box, I'm very quickly also going to take a snapshot. This is something that I know a lot of people were re-importing the OVA if they tipped over the box. You can also just do a snapshot and roll back. I'm going to be showing one thing in particular that will junk up a file that we will use for the actual demonstration. So I'm just going to have that snapshot so I can easily roll back later. So I'm going to turn on the box and make sure that it gets to the login screen okay. The new login screen on this OVA will show the IP address of the box. I'm also going to show you how you would get the IP if that wasn't the case. On occasion, if you're downloading, say, a VulnHub machine, they'll give you it'll be set to a static IP, and they'll give you that IP, so you have to match your attacker machine to that. Sometimes it'll just DHCP. I have this noob2root machine and my Kali box bridged directly to my home network. So I am getting directly a 192.168.100.242 IP. And if I go over here and do an IPA on my Kali, I have 192.168.100.229. So they're both on that 100.0/24 network. So if I didn't know the IP of the boot2root machine, I could use a couple utilities to figure out where to start poking around. So one of my favorites that I like is doing fping. The syntax I use is tac-g and then your CIDR range. So for me, that's that 100.0/24. Then tac-a, tac-q. If you run this, it'll automatically expand that CIDR into the 100.1, 100.2, all the way to 100.254, all the way through, and then it will show you which hosts are live, and it won't output anything for the ones that are not alive. So because this is on my network, I can kind of cheat a little bit because I know what all my other devices' IPs are. And I can see that there's that .242. You could also, you don't have to use fping. There is in nmap, you can do tac-s, lowercase s, capital P, and then the CIDR. And it will also show you which hosts are up, but it does give you the host names as well. So for this one, you knew that it was Redcorp Web, so you could have found it a bit easier that way. fping, you could have saved this into a text file, and then if you weren't sure which one on your network, or which IP was the actual thing on your network, you could have fed that list into nmap with tac lowercase I, capital L with a list. But those are just the basic ways of finding what IP could potentially be the machine on your network. There's also NetDiscover. That will not work in how my network is configured right now, so I won't demo that. But plenty of other ways. Keep in mind that some advanced boxes might be blocking ping, or if there's a firewall in the way, it might be blocking that, so you have to use other methods. I won't go into that right now. We're just going to focus on the actual boot2root box right now. So one of the first things that you want to do with any box is figure out what's actually running on it. So the default tool that we use for this is nmap. So I'm going to do nmap sc svoa init and then the IP. Normally I would also put -p- right here to scan all of the TCP ports. I'm not going to do that because it doesn't matter for this box, but if I was doing, say, a hack-the-box machine, I would definitely do that, as some stuff can run on the non-standard default 1000 ports nmap does. If you don't know what the other flags do, -sc will perform any enumeration scripts like this HTTP server header and title, or if there was SMB, it would pull up other information for there. So that's what sc is doing. SV is getting this version information that the service is advertising. OA is outputting in every possible format that nmap does. I believe there's 3. and I'm just calling it init. So if I actually ls in this directory, we have init g nmap, nmap, and xml. XML can be used in a lot of other tools. Init.nmap is essentially a text file with this right here, and gnmap is a greppable nmap, so if you wanted to search a bit easier through your output, you can definitely do that with a grep in the greppable form. So that's what all of that is doing. If we look at the actual results here, we only have two things open. We have SSH running on port 22, the default, and we have HTTP also on the default port 80. So OpenSSH 8.2, that's pretty up to date. We actually do a search exploit on OpenSSH. See that there's not anything up. You generally won't find anything using SSH as an initial vector. It's more for if you find creds to get in later. So we're going to focus on the Apache instance. So another thing that we might not immediately know, like from here we could see, if we go back to the actual vulnerable machines like login prompt, we can see that it's Ubuntu 20.04.1 LTS. If we didn't know that, we can tell that it's running Ubuntu. If we wanted to know the actual version, the nice thing about Apache is that we can go and, by using that fingerprint, figure out what we're doing. So if I search Apache 2, and then it was 2.4.41, and then just search Launchpad to go to the repos. If I go to 2.4.41, I could see up here, it might be a bit tiny to see, but it does say Focal 2004, so we can get the version of Ubuntu that way. Sometimes that will matter for further enumeration things. I don't think it affects anything on this box, but that's just something, again, to know for future boxes. So we're going to investigate the website. If you are new to this, and if you're trying to get into Hack the Box, there's a really good YouTube channel, Ipsec. He always has some sort of reconnaissance going in the background, and I like to do that as well. So because it's a website, I'm going to quickly make sure that there's actually something running there that we can see. So if I go to 192.168.100.242, I do see a website here. I see a couple links. So in the background, I'm going to run gobuster to try and brute force any potentially hidden directories that we have. So this is my syntax for gobuster. I'm going to tell it to enumerate directories at this URL. And I'm going to use a word list that's built into Kali. Dirbuster actually has one of the better word lists, in my opinion, besides seclists. This is just one of the default ones in there. It'll normally hit anything for most challenges that you'll see if you use the medium size. So I'm just going to have that running in the background. It's already found some of the static, like image, CSS, JS. But while we poke around this website, looks pretty standard. There's a couple, like, names, like, just your typical website. I do see this number down here that might be a bit interesting. So if you see a number below, the number service is running great. Kind of interested in a number service that they're talking about, so I'm going to inspect that element. And I see that there's something called announcement. I do want to know what's going on, so if we actually go into this was the JavaScript inspector, by the way, so it's just inspect element. If we go over to the debugger tab, we can see all of the JavaScript that's being loaded. So if I open this and open data, we see some like name stuff being generated in the background, lots of arrays. We go through here, there's all sorts of stuff. Eventually, if you were enumerating this, you would have found the number service, and we see that it is fetching the contents of this page. This is a dir proof directory. So, spoiler alert, our gobuster would not have found this directory. It already went through the entire list and did not. And so we have this as sort of a thing. We wanted you to triage the JavaScript or the pages itself or intercept requests, then you might have potentially seen this directory come up. So if we go to that page, I'm just going to copy that and go, oh gosh, okay. Well, I will just copy it from over here into the VM. There we go. So if we went to that page, we see numbers. If we keep refreshing, just appears like it's a random number, no big deal. So this page is pretty bland. If I go to inspect element, it's just 360. It makes sense because we won't be able to see the PHP generating this number, so it's just the output. I am curious to see if there's anything else in this directory, so I can go just delete that and go there. And we see that this directory is indexable, so we can actually see all the files that are inside. So we have that server status thing. I want to see what this fired.txt is here. And so this looks like a text file from the breadmin user, the bread admin. So we can pull out a couple hints from here. We see that there is haven't changed the default log locations, but he did make it so everyone can read the log files if they need to. So I made a note of that while I was going through and kept that in mind. So then I went back, and the other thing that we haven't checked is Announcement.php. And when we go to that, it says you didn't provide the secret parameter. Once you have the parameter, the announcement name is fired.txt. So again, if we inspect the element on the page, we just see that text, so we don't have any like hidden comments that might leak stuff or any external JavaScript that's being pulled in. So it says that we need to provide a secret parameter. Well, if you want to provide a parameter to a website, you can go to the end of the URL and do a question mark, then you can go like secret. And then if you want to assign a value, it said that once you have the parameter, the announcement name is fired.txt. So I'm just going to try fired.txt right here. And I can see that this is the contents of the text file that we were just looking at. So with this parameter, we can read a file on the system. If we didn't have that hint about the secret parameter, if we assume that there might be a parameter, but it wasn't immediately obvious that it was supposed to be the word secret, we can do a technique called fuzzing. So the tool that I like to use for this is wfuzz. So I'm going to remove one thing from this command really quickly. So we have wfuzz-c-z file, and then I have a word list. I'm just using the generic wfuzz common word list. I'm ruling out any page that goes to a 404, and I give it the URL that we're looking at, and then the question mark, and then the word fuzz. So anything that's on that common word list will be inserted where the word fuzz is. And so right here, it'll try and find whatever parameter we can. So if I run this, we can see that everything that's on that word list comes back as a 200 OK with 104 characters. So if I know that that's kind of the flag that's making it not, like, I don't want to know that everything came back 200 OK. I want to see if there's any differences from that. So I'm going to do a tac HH 104, and that will hide anything with the with 104 characters. It's a bit weird because C is a status code and H is characters. You'd think that it'd be C, but it's not. So if we go ahead and run that, I will see that we found that secret parameter was the only one that returned something that wasn't 104 characters. And so that returns 0, because if we do secret without anything, we just get an empty page. So that's one way that you could find the actual parameter. But now we know we have that, so we can go ahead and read. We know that we can read something that was in the same directory, right? Because Announcement.php and fired.txt were in the same directory. So the thing that I want to check is if I can read files in other directories. This is called a local file inclusion. So we're trying to see if we can include any local file that's on the box. So if I do a couple ... slashes, I'm just going to put a series of 10 up there. That should, in theory, bring me to the root of the file system, because we're probably in like var HTML on the actual system itself. So if I just path traverse all the way up to the root, I can try and see if I can read like etc password, for instance. And I do see the contents of that, so I can read whatever file I want on the system, provided that the user that the website's running at has permissions to see that. So we're trying to think of what file we can read to give us an advantage. Because if we can read whatever file, if we can modify a file, since this is a PHP script, if we can inject our own PHP into some other file that we have the ability to read, we could run arbitrary PHP commands, which could lead us to a shell on the system. So the thing that I want to look at, it also, in the note on the fired.txt, we had a hint that the access logs were not changed from their default, and anyone could go read them. So for Apache, the log instance is var log Apache2. There's access.log, which we can read. This is why I took that snapshot, because when I did the gobuster command, it's going to have a lot of requests in here, and it's going to be a pain to find what we want. So I will be reverting the box in just a second. So we have access.log. There's also, Apache has like an error.log that we can see, but the main thing that we will be doing is exploiting the access.log. Very quickly, I'm going to go ahead and just revert the box to that snapshot. Let's boot it back up here. I see it still has 100.242, which is good. So if I go to look at the access log now, I'm not going to have anything. So if I go to error.log and then go back to access.log, I can see that we now have entries, and it's much easier to see what's going on. The reason I didn't have any entries is because on a fresh instance we hadn't accessed anything yet. So if by accessing error log, it does create that file, and then it links that in there. So one important thing to notice when we see these GET requests on the access log, we can see the path that someone is trying to get to. So for instance, right here, I can see I was trying to get this from the server, because this is our server, this is the file that we're trying to get. And then we have some other like miscellaneous things. There's a dash, and then this is our user agent string right here. We can use this to our advantage to actually put PHP in here, because it doesn't matter what we send as a user agent to the server in most cases. So what I'm going to do is I am going to use Burp Suite to capture this request so we can play with it a little more. I have this extension called Foxy Proxy that you can add to, I'm using Firefox on Kali. I just have this to where I can toggle whether stuff is going to my Burp proxy. And over here I have Burp, and I'm just going to turn intercept on. So now whenever I make a request, Burp will catch it before I do anything with it. So I'm going to reload the current page. Burp pulled it up and we're good to go. I can see this request. I see the user agent field right here. I'm going to clear that out, and I'm going to try and inject another parameter onto the page. So it'll be a bit easier if I just type it and then explain what's going on. So I have PHP system $_ get, and then inside of an array, cmd, and we close our parentheses, clear the line PHP, and then have our closing tag. So what this is going to do is we will have this parameter on the page. If we provide the cmd parameter, it should be ran inside a system call. So if this works, we can just pass whatever command we want to run on the box inside of the cmd parameter, and then get code execution through this. So now that I've modified that request, I'm going to head and forward it, and I'm just going to turn intercept off and let everything else forward through. So if I go back through, if I refresh this once again, if we look very closely, we will see we had a couple GET requests here. We should see a GET request that does not have a user agent associated with it, which yet is right here. So this GET, starting right here, we see the GET, the 200, 460, or the 203, the two numbers. There's that little dash, but then we see this pair of empty quotes right there. So we didn't send an empty user agent string. It's just PHP doesn't show the PHP tags itself on the page in most circumstances. So if we try to do a parameter right here, such as, we already have one parameter as our secret, right, that we found. So if we need another parameter, we can just go and cmd equals, and if I do like who am I, instead of having blanks right there, we have the output of the command that we had on the box, as well as the GET requests that will keep going. So whatever command we run, the output will always be put in that spot on the page. So we've successfully poisoned the access log to run our own commands. We have command execution. I can see who am I? I'm the www data user. If I do a host name on the breadcorp web box, So now we know that we can run commands on the remote host. So what I'm going to do now is attempt to get a reverse shell as the www.data user that we know we're running as. So if I go back over to my terminal, I'm going to set up a listener. I'm going to use nc tech lvnp, and I just use a random port. Due to my username, I use 5252. You can do whatever you want, 1337, 4444. If it's a protected port, you will need sudo permissions. If you wanted to list something like port 80 or 443, then you would just throw sudo in front of there. So I have this listener going on port 5252, so it'll catch any connections going back. You want to make sure your listener is started before you attempt to send something to your listener. Otherwise, it's not going to work, right? When I normally get to this point, I like to pull up the PenTestMonkey reverse shell cheat sheet. If you Google that, you will be brought to this page. There's just one-liners that can send you as an attacker a reverse shell back in various forms. I'm partial to this Python one right here. I haven't had too terribly many problems with it. So I'm going to just quickly check if there is Python on the box by doing which Python. And I see that there's no output right there. So I'm going to check if there's Python 3 on the box. And I do see that we would be using the user bin Python 3 executable. So because there's Python 3, the PenTestMonkey one-liner actually works with Python 3. You just need to add, specify Python 3 right there. So I'm going to go ahead and copy this and just paste it into our command parameter. Change that to Python 3. Come over here, and this is going to be what the remote machine connects to. So this needs to be the attacker's IP, or in this instance, the IP of my Kali. So I'm going to go 192.168.100.229 is what I have my Kali set to. This is the port that we will be connecting on, so it will be 5252 in my instance. And I'm going to go ahead and everything else to be left exactly the default. So I'm just going to hit enter, and I see that this page is loading. Now normally on this box everything has been pretty quick, so this is generally a good sign if you're doing something like this, because if we go back to the terminal, we do see that we have a shell. I can go who am I on www.data on the breadcorp web box. So we do have our shell. The one thing you want to keep in mind, because we were using this sort of web thing, if I hit the stop right here, I would no longer have that shell. I would not be able to interact anymore. So from here, we just want to keep this tab open in the background. If we found credentials, we could, for a user, we could go SSH in because SSH was on the box. For now, just leave that tab open. We shouldn't need Firefox anymore anyways. So one of the first things I do when I get into a box is I upgrade to a full TTY. If you're doing a Netcat listener like this, you're not going to be in a full featured TTY. So if you try to do something like sudo tech L to see what permissions you have, it says the terminal is required to read the password. So since we have Python 3 on the box, I'm just going to go Python 3 tax C. I like to use single quotes here. So if I go import pty, pty.spawn, then parentheses, double quotes. If you're the kind of person that uses double quotes on the outside, you would use single quotes here. Just make sure that you match them how you need to. So I'm just going to go bin bash, close my single quotes, close my parenthesis, and close my single quotes. So now we have a full prompt thing right there. I'm also going to export my term variable as xterm. So now I can run the clear command, and it's kind of like I have a sudo shell. So if I do sudo tech L, sudo shell, not permissions as in sudo as in like a fake dummy shell. So if we go sudo tech L to try and see what we can run, occasionally you might have a no password command that you can run as root, which is a really easy prevents method. But it's prompting me for a password, so we're not going to get anything out of that. We did get something out of there. A lot of the times you'll see something as a GTFObins type thing. So if we Google GTFObins, if I turn off going through Burp and then Google GTFObins, if you did have something popping up, you could search like Vim, for instance. You can be like, here's how you get a reverse shell with Vim, and it tells you exactly what you need to run. So if I go through here, so from here, I do want to perform some enumeration to see if there's any misconfigurations on the box. Since this is a Linux box, I will be using the LinPeas script. So I'm going to navigate into the /temp directory so I can drop a file onto the system. This bottom terminal that I'm opening down here is going to be on my host Kali machine. So I have this script inside of opt called LinPeas. And if you have not heard of LinPeas before, again, if you Google most of the tools that are being used, that'll be the first or second link. LinPeas is the Linux Privilege Escalation Awesome script. It is a very nice way of trying to find initial vectors when you get in for privilege escalation. Some people use linenum. I think LinPeas is a bit more featured and fleshed out. It's newer. There's some other auto things that does some really nice syntax highlighting. So I will be using that. So I have this on my Kali system, and I want to transfer it over to our target, the bread machine. So in this particular environment, I technically could just download LinPeas from the vulnerable system directly, since it's directly connected to the internet. However, if you're doing this in like a hack-the-box style way, the only thing that the vulnerable host will be able to talk to is your Kali machine. So I have LinPeas downloaded on Kali. So I'm going to serve up a Python HTTP server. So if you do sudo python3 tacm http.server on 80, anything that is in the directory that I run that from, in this case /opt, I can go ahead and pull from the vulnerable machine up here. So if I wget to my attacker's machine, which is 192.168.100.229, if I just download linpeas.sh, you can see down here we got the request, and I spelled LinPeas wrong. So if I wget into 168.100.229, linpeas.sh, there we go. So we see that it's saving the file. We did get the request. It was a 200 OK down here. So the file has now been transferred and copied over from our attacker machine to the vulnerable machine. So I'm going to go ahead and close my web server. Just exit that pane. And so now if we look in here, we do have our linpeas.sh. I'm going to go ahead and make that executable with chmod +x linpeas.sh. Then I'm just going to run linpeas.sh just as the default. So we see it puts out this lovely, the LinPeas logo, creates a couple directories, and it'll just start going off and analyzing everything that it possibly can find, which is very nice. One of the things that I appreciate about LinPeas, if I scroll all the way to the top here, is that it has a little bit of a legend. So if we can see this red, yellow, if anything's highlighted like that, it is most of the time going to be the privilege escalation vector that you want to look at. Whereas red, it's like you must take a look at it. It's probably something that you can exploit with a little bit more effort. And there's a couple other things that it highlights as well. So going through the output here, it's still going. It goes through a lot of methods of privilege escalation, just trying to see everything that you can find on the system that could help you get your foothold. So now that we're done, we're back to our bash prompt down here. So I'm just going to start scrolling up through our output. I'll actually start at the top again. So we go up to the top where we ran it. We see the operating system information, confirm that we have that 2004 that we found earlier. Pseudo versions, our path, the date, system statistics, CPU architecture, yada yada yada, environment variables. One of the first things that you get to is a weird and unexpected processes run by root. And the nice thing about LinPeas is it also has these links to go find more about these particular privilege escalation methods. If you're interested, definitely consider looking at some of these if you haven't heard of any of the methods before. So if I look at these processes running as root, everything seems pretty normal. And then we get down to this last process running here. I see Python 3, C, import PTY, PTY spawn bin bash, which is the thing that we typed earlier to get our pseudoTTY. So but we were running that as the www data user, so it's a bit interesting to see that that process is actually being ran by root. So I want to investigate why that is. So what I'm going to do is I'm going to go which python3 just to get the path of that. I see user bin python3. So if I lsal on user bin python3, I can see that it is actually a symbolic link. We can see this by that L character at the beginning, pointing to python3.8 in that same directory. So if I lsal and then user bin, not type today, user bin python3.8, I can see that we have our normal permissions over here. When you look at files on a Linux system, you'll have your read, write, execute permissions. So we had to set that executable bit so we could actually run the thing on LinPeas sh. But up here, we have read, write, s. And s is what we call the sticky bit. So whenever Python 3.8 is ran, it is actually running in the root. The process is going to be owned by root, so you could do some privileged things. Like you could temporarily use root's privileges to aid you in that task. Normally, Python 3.8 does not have the sticky bit set, so this is the intended privilege escalation method that we had on this machine to identify that what you were running as was a sticky bit binary. Further down in the LinPeas enumeration, we do see set UID binaries. So if we go through here, I'm trying to look for Python 3.8 right here. So we can see that we would also have seen the set UID right there as well if we didn't have a process running. If you hadn't upgraded to a TTY, or if for some reason you got in and didn't use Python, this would also have been a key indicator for you as well. Note that LinPeas does not highlight this in any way, but if you see this, it is most of the time going to be guaranteed a privilege escalation vector. So what we can do is if we run I'm going to go ahead and clear the screen here. If we run Python 3, we're dropped into the Python interactive shell. So the way that you would privest this is you can go import OS to import that library into this current session. So if we go os.setUID and call that with the parameter 0, that will set the user ID that the session is running as root. So the process is already running as root, but we need to tell it that we want to switch over to the root user to do our next little bit of instructions. So now I'm going to import the PTY module, and I'm going to use that same PTY.spawn bin bash. And then I can see right here I am root at breadcorp web. So if I do a whoami hostname, I can see root breadcorp web. And at this point, you have a full root shell on the system. Most of the time, if you were doing like hack the box, you would have a flag to go grab in root on Linux. So it'd be like root.txt. We didn't have a flag on the system. We just wanted you to get a shell and prove that you had a shell. If you wanted to have further proof that you were root, you could like cat etc shadow to see the actual hash of the users. We did have this breadadmin user, which I don't believe you needed to get into in any way. We intended for you to go straight from www to root. So if you got in there, props to you. There are other methods that you can escalate to root by. A lot of them were not intentional at all. We mainly made this method of finding the Python 3 set UID bit. That was how we would go through the box, some methodology, some extra things that you could utilize for other boxes. I hope that people learned a little bit going through this box. If you didn't get through it, that's okay. The OVA is still going to be up at the link that we had in there. If you need that link again, feel free to message any of the officers of OffSec. We'd be happy to send that to you. If you want to mess around with it, follow along with the video, totally get that. If you have any questions, please feel free to reach out. Otherwise, that's all I had. Thanks for watching.